do some quick audit. Okay. Two charges. Let's have some electric charges. So you can say like two types of charges. One is positive charge. One is negative charge. Positive charge. These all things you know, I guess. So charges, positive. So positive charge means it was deficiency. You can say deficiency of electron. Efficiency of electron. Now, when some electron, when some particle or when some matter or any matter which loses charges, it gains positive charge. It has deficiency means it has like when charge is what any matter when it has deficiency of electron, it gains positive charge. When it has excess of electron, it gets negatively charged. So that matter, it gains negative charge when it has excess of electrons. So SI unit of charge. Can anyone tell me what is SI unit of charge?
Coulomb.
Yup, it's Coulomb. Symbolize as C. Okay. And it is a scalar quantity. So charge we can define it is what? What is charge? Can you define what's a charge? Just not X definition, just simple one line. Yeah, what's a charge? Anyone? Chanakya?
I'll try.
Yeah, sure.
It's a property of a material to attract or repulse.
Attract or repulse. Okay, nice. Charge. Can you hear me, Raj? No? Okay, Samhita?
Sir, it's either a positive body or a negative, positively charged body or negatively charged. I don't know define it, but then.
Yeah, doesn't matter. Whatever it is, you tell me.
Body which possesses either a positive charge like a negative charge.
Okay. Okay. So let's combine both answers. Okay, so he said like it is like it attract or repulse any matter. So attract or repulse, just I will add here in presence of electric field or magnetic field. Okay, so those are charge which attracts or repulse or whatever it does. in presence of electric field or magnetic field, or due to effect of magnetic field or electric field, whatever. So which has two things. We said just now, that is positive, and another one is negative. So when this matter has deficiency of electron, it gains positive charge. When matter has excess of electron, it gains negative charge. Now, how to know this? Like simple example, if I give you the simplest example, when we are rubbing our hand, we assume that from left hand, it's not necessary left to right. This is our assumption, our convenience. We are saying that it's moving from left to right. So if it is moving from left to right, what will happen to left hand?
Sir, could you repeat?
When we are rubbing our hand, okay, so from left hand to right hand, charges are moving. So what charge left hand will gain? Positive or negative?
Positive.
Positive, because left hand is giving charges. So it's moving from left to right. So left will gain and right will accept. So excess of electron will give you negative charge. Some standard, if I give you like positive, it is assumption. Okay, it's not exactly this way. It's just assumption, like glass rod, silk, fur, and some ebonite's rod. Dry hair and comb. In your when you were a kid, so I guess you have done all this, right? You have taken this glass rod and some paper like that, and dry hair with comb. That hair will start like flying or getting attracted towards comb. Wool and umber. These are some standard. Actually, yes, this is also our assumption. Okay, exactly. They don't have any charges. But one thing you have to assume, right? Just now I gave assumption. Okay, from left, my charge is moving to right. So it's not necessary like that.
Yes, sir.
So when we are moving this glass rod and silk, suppose all this left column and right column, when we are rubbing here, so that is called charging by friction. We are gaining or losing our whatever is happening here, charge transfer. That is called charging by friction. Even just now, whatever example I gave for hand rubbing, that is also charging by friction. So next is your charging by conduction. So we are conducting, like from when it touch, like it just starts conducting, like whenever electron passing from the conductor, right? So electrons are touching inside. So simply, it will, if you touch the wire, I will also start conducting, and I will get shock. That is what charging by conduction. And same way, charging. Next one is your charging by induction. Charging by induction in the sense like if you remember, you studied in 10th standard, like what was that? Electromagnetic induction. If I'm not wrong, it was like that, right? Electromagnetic induction. So in that, what we were doing, we're taking one insulated here, and I'm connecting wire here with the galvanometer. and I'm bringing, this is a solenoid, I'm bringing some magnet, north and south. So if I bring it inside, so this will get deflected toward this direction. And if I'm bringing outside, it will get deflected towards this direction. So deflection calorimeter shows there is a current moving here inside the coil. That is what, without touching, it is inducing current. So that is what charging by induction. So what are three ways we saw here? First one, charging by friction. Second, by conduction. Third, by induction. So in friction, what is the friction? Excuse me.
And we rub two surfaces together.
Yeah, rubbing. What was conduction?
We place an electric field or magnetic.
Yes, yes, yes. Correct. Electric field or magnetic field, whatever. So we are just touching it. And induction, it was short term. Just I want one word for induction. What we did in induction?
We place a object with current flowing through it next to an object without current. It gets induced in that object. I don't know how to define it, but
Okay, so one word we will use something like without touching. Let's write without touching.
yeah.
Without touching. Just we brought nearby. So it got induced. We are touching it. We are rubbing it. So this is what charging by all these three ways. Okay. Now we'll see properties. Of charge. Okay, so property is like a simple, it's very, very easy. We can start like this, something, yeah, like charges attract, right?
Yes.
Similar charges means like charges attract. Yes.
Yes.
That means plus and plus will get attracted. That's what it means.
No, sir. Unlike charges attract each other.
So like charge, repel.
Well, yeah.
Like charge, similar charge, repel. And this similar charge attract. So if I place some plus, this will repel. So if I draw electric field, we'll see that later. And this similar charge get attract. Now, actually, sometimes this similar charge also attract. It is a very, 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 very rare case. But how it is attracting? If it is a big, big positive charge and one very, very minute positive charge, one big positive charge and one very small positive charge, very, very negligible positive charge. So obviously it will attract towards him only. This will attract towards him only because it's very minute. But this is actually like negligible case. Okay, so this first thing we saw, and next. So the next thing we'll remember, like we can say, when there is a charged body, it will always attract uncharged body. Uncharged body due to polarization. I guess you're written here. So when this, suppose this is some charge body. And this is the wall and some uncharged bodies here. This we can say positively charged body. So actually it was uncharged body, but due to presence of positive charge, this negative charge got attracted towards the wall due to presence of this one, positively charged balloon, something. Doesn't matter. Any body or balloon, whatever it is. So this negative charge will get attracted towards this wall. So this condition is called polarization. So there will be, due to this one, there will be exchange of electric field. So whatever it has, suppose it's positively charged balloon. If it is negative charged balloon, this will be attracting here instead of this negative. It will become positive. All this depends what charge this balloon or whatever material, whatever it is, it has. So this is uncharged body. So when there is an uncharged body, it will just try to attract whatever opposite charge it is. Okay.
Yes, sir.
Chalo, next. So charge is conserved. The charge is conserved. Conserve means neither created nor destroyed. So even in like a nuclear reaction, when we are seeing that there is a just transfer of charges, energies, we can say. Like it is just uranium is splitting and forming two other thorium or barium, whatever it is, depends upon what reactor we are using. So it will be giving some number of energy. It just energy is converted into two other energies. In short, total energy remains constant of all this product and resultant. So that is a charge is conserved. Fourth one. So this one is just common thing. It is not, we can say, charge is not affected by some movement. Motion. See, in previous class I said, like charge is not affected by motion when it there will be no change in charge when it is moving. Even in mass also, there will be no change in mass if it is object is moving or whatever is happening. But only change is like it will only change when mass will only change. There is only one condition to change mass. That is when object or any particle should travel at the speed of light. That's what it was given by Einstein. So this charge is unaffected by motion. So that means charge at rest should be equal to charge at motion. It will not change. And fifth one, last one, we can say quantization. Quantization of charge. Simple, in simple terms, Q equals to NE. It is integral sum of the charges. So here N varies from 1 to infinite. And what is charge of electron? Can someone tell me what is charge of electron? No one knows this.
1.68 into 10 to the power minus 90.
1.67 into 10 to the power minus 19 unit
Coulomb.
Coulomb. Very good. Okay. So any doubt in these properties? Properties of charges?
No, sir, no doubts.
No, sir.
Okay, anyone want to make a note? You can. It's just simple properties. Or you can remember whatever way it is. You want me to scroll up or down? Then
Yes, sir.
okay. Then next is your Coulomb's law. It's very simple. Now we have two charges, Q1 and Q2, which is separated by distance R. So either it can be attractive or repulsive. So force between them is directly proportional to, let it be attractive or repulsive force, directly proportional to product of two charges. And inversely proportional to the square of distance between those two charges. And this proportionality we are removing by 4 pi epsilon Q1 Q2 by R square. So your epsilon is the permittivity. Or medium. Medium between those two charges. So you can say EM also. E R relative permittivity, or we can say K equals to epsilon by epsilon naught. So here this is your relative. See, this relation you need to remember, it will be very, very helpful. Not for board exam, that much won't be much problem for board exams, but yes, for JEE exams will be required. Okay. So this is for free space. Relative permittivity is the ratio of medium to the free space. Free space in the sense vacuum or anything. This is for medium. in simple terms, let's say permittivity means to stored energy, how much it can store potentials. Or write like this, we can say ability, yeah. Ability to store potential. So inert is a for free space. Its its constant value is epsilon naught is equals to 8.85 into 10 to power minus 12 Coulomb square Newton inverse meters square, or you can say C by Nm. And this we got from a formula itself, because we know force, we know charges, we know R. Make a note of it. Okay. I guess done. Is it done or you're writing?
Yes, ma'am.
Okay. So next, we'll see here. See 1 by 4 pi epsilon naught is equals to 1 by 4 into 3.14 into 8.85 into 10 to power minus 12. Can you multiply and divide 1 by this one? Can you tell me the value? So we can say F naught by F equals to K. So F equals to 1 by 4 pi epsilon Q1, Q2 by R square and naught equals to K. So with this one, we can say F naught by F equals to K. Okay, so what do you get here? If you divide 1 by 4 pi epsilon naught, Anyone did multiplication? Chanakya, Samhita, Ajay.
Sir, I'm doing it 1 second.
Acha. No calculator, okay? Do it yourself. Done? Yeah, it is something for my.
Sir,
Yes?
sir, is it 11.1 into 10 to the power 15?
11 point.
11.1 into 10 to the power 15.
No, dear, it's not correct. 24. 96. It will not be 15, it will be around somewhat around 9, 10. 8.99 into power 9, yes. So you can say approximately 9 into 10 to power 9. That's a value actually. So this, now onwards we will use this value as a K. So F equals to K Q1 Q2 by square. Until they mention some medium, we will take free space only. So free space value is 8.85. So this will be our value. Now onwards, 9 10 to power 9, which makes our half of the calculation easy. So this is what we say, its name is dielectric. Dielectric. Now what is dielectric here? It is like some insulators. Insulator, like see, insulator in the sense not exactly the insulator, but when it is when it has some electric field, it will start conducting. Conducting in the sense not as conductor, not even a semiconductor, but just a very minute semiconductor, you can say. So actually these are dielectric, they are insulators only. It will used as insulators in so many places, like we have condenser in our fan, right? In condenser, it is just inside condenser. If you see some material, it's not sticky material, but it's some hard and soft material. We can break it like some, what is it, cement, cement type thing. It's not cement here, but similar way. So it is stick around that conductor inside that plastic, what you see outside that. Have you seen the condenser outside, from outside at least? Condenser in the sense capacitors of fan, that white color. It will be like this cylinder, small cylinder. Have you seen this? Some name will be written here. Have you or haven't?
Sir.
Sure. Okay, so let me show you that. So you'll have a better idea. 1 second. Capacitor for fan. Okay. Taking so much time, huh? taking time to load. Okay, fine. Let it be. Yeah, I got it. Yeah. It will be like this. Charging and his work is to charge and discharge. Now, if I do a cross section of 8, in this one, this is inside the material. Okay. So between material and this wires here, there will be some other thing to not get conduct easily. Okay, so there will be like outer layer here. That is called dielectric. It's like insulator. It will insulate this thing, whatever material we have inside. It will just insulate so that there will be no external influence from the environment. Okay, in simple terms, it's just an insulator. Tomorrow we'll see some other forms, some numericals we'll see. Okay, and see you tomorrow.
Thank you, sir.
Guys, bye-bye.
Thank you, sir.